This is the refresher training for Science Unit 1, Lesson 4 on the role of calories. So in this lesson, students are going to integrate ideas from lecture, lab, and text to understand the role of calories. They'll also conduct a lab experiment where they will develop a hypothesis, read and follow directions for lab procedure, gather and record data, and write up a lab report. So they'll also learn to analyze data and confirm, modify, or reject hypothesis. So the first thing that they're going to do is read a textbook section and a research article on the role of calories. And so what you need to know is that students are going to be using several different reading strategies for these texts. First, they're going to use annotations, so you want to remind them of all that good stuff that they learned in Lesson 2 about how to annotate science text. Then they'll also be using text-dependent questions that are in the lesson plans for a discussion on the role of calories in the text that they're reading. And then we'll also ask them to respond in writing to some other questions that are in their academic notebook. So they really need to pay attention to both the article and the text as a way to get them to prepare for the lab. And that's activity 2, where they'll actually conduct a lab. So what they need to do is conduct a lab to determine the amount of chemical energy stored in food by burning the food and capturing the heat given off using a homemade calorimeter. And the goal of this lesson, or this part of the lesson, is not just to be able to do the lab, but also to be able to read and follow the directions. So it's that step-by-step careful analysis of what they're being asked to do using several different protocols to conduct the lab. So it's important for teachers to prepare a few things before the lesson. The first thing you need to do is build a calorimeter. So don't panic. Science teachers in your school most likely already have calorimeters, so this might be a really good time to pair up with a biology teacher. If that won't work out, if there aren't any calorimeters and no science teachers available to you, there are directions for building one in the lab directions using 2 cans, a thermometer, a cork, and several samples of food. So it's a pretty easy build. There's also directions for an even simpler calorimeter, but that's a much less accurate build. So the one that uses the 2 cans is a much better way to go. Or another option is that there is an online lab, and so if you go to this link below, there is an online calorimetry lab. And in this, students can virtually burn food. And so it has most of the components of the lab, but it's less self-directed. So in other words, it's a very step-by-step lab. And so if you use this particular version, students are going to miss out on that learning how to read and follow lab directions. So it's a less good model, but it is better than nothing. I say the first thing to do is go visit the science people in your building and see what they can do to help you out with this one. Okay, so students not only need to conduct the lab, but they also need to write up a lab report. And so in the academic notebook, before even the directions to the lab that they're about to do, is some sample lab reports. And so we've entitled them the good, the bad, and the ugly. So you want them to look at the different lab reports and pull out what's good about the lab reports, what's missing from some of them, and what can they learn from these samples for their own lab, so that when they're writing them up, they do the best job they can possibly do. It's a good idea to talk about how to collect the data for the report, and there's lots of places in the academic notebook where they can use the charts to fill out their data. It's good to talk about what makes a strong and a weak and strong lab report. So there's that chart there of some sentences that you can use that make a stronger lab than others. It's also a good idea to talk about what makes a good hypothesis. And so as they're setting out their lab and as they're figuring out the order in which they're going to tackle measuring the food, they should be creating some hypotheses that they can answer as they go through the lab. In the academic notebook, there are some sentence starters that students can use to help them get through all of this. So it's a very supported way in thinking about conducting a lab. It's very important to allow time for students to make sense of the directions. So introduce the prompt, which is after reading informational text from Belkin-Meyer, Chapter 4, Section 1, and the Scientific America article, looking at the sample lab reports and looking at lab procedures, developing a hypothesis, and conducting an experiment examining the chemical energy stored in food, write a laboratory report in which you explain your procedures, results, and confirm or reject your hypotheses. What conclusions do you have? So getting them started thinking about the end is a really great way for them to structure conducting the entire lab. So their goal is to be able to write all of this up in the lab report. They know that they need to be able to collect all that data as they go through working on the lab. So what students need to do as they go through the lab is to be able to organize their findings, calculate their results, and write up the lab report. They can use the sentence starters for the lab report if they want to guide their organization, but it certainly is not a requirement. We've had some teachers think that these are like a Mad Libs fill in the blank. It certainly is not. And as you look through them, you'll see that it's just multiple sentences that they can use to get them started in writing scientific ways of representing the data. So it's important for teachers to know that the sentence starters are only there as a guide, and that students should be looking at that grading rubric to make sure that they've addressed all the important criteria in their report. And the grading rubric is in the lesson plan. It's also in the academic notebook. So they can see exactly what you'll be looking at when they turn in the final report and what you'll be looking at as they conduct the lab in the classroom. It's important to provide some class time to work on the report so that they can share their progress in small groups. Because this might be a more full-blown lab report than they're used to writing, they may need some time to work out some details with folks to give the level of detail that we're really looking for each part of the lab. And here's an example of the rubric so that you can see that they're graded over the introduction, the hypotheses, the materials and procedures, the results, and that includes a chart of the data, their analysis, and their conclusions. They're also being graded on grammar, sentence structure, and vocabulary. So is their terminology precise? Are their sentences tight, succinct, and in scientific writing style? So each of these is graded on a 4-point scale, and they'll be able to look at that at the beginning to see what are the criteria on which they'll be judged. And that is really Lesson 4. Lesson 4 concludes with the second weekly reflection. And so in this one, they will again reflect on 2 levels, on the science that they learned since week 1 in week 2, and also the strategies, the reading and writing strategies that they learned to learn the science. And so again, we're asking them to think on those 2 levels. It's not just about learning the science content, but it's also about learning the strategies that are most appropriate to use for the tasks. And that is Lesson 4.